Okay, so let's talk about 4 equations in 4 variables. How would we do this? So the first thing we need to do is we need to do an augmented matrix. 1, -1, 2, 1, 3, 3, -2, -1, -1, 4, 2, 1, 2, -1, 10, 1, 2, 1, -3, 8. Okay, now my first one is 1. I would have to make all 3 of these equal to 0. Or I can even make this a little bit easier. I can actually say, wait a second, why don't I do this? Second matrix. I'm just going to edit my 3 by 4 a little bit more and make that now 4 by 5. All right, 1, -1. You can pause the video and put this in your... Okay, so once your matrix is in, we're going to go to... Actually, I like to quit out of this. So go back to matrices, go to math, go down to reduced row echelon form, which is also alpha B, so it's alpha apps if you really want to do that. And I'm going to put in matrix A again. Hit enter. There it is. So I go ref of A, and then that equals 3, 2, 1, 0. So x equals 3, y equals 2, z equals 1, and w equals 0. And I had to do very little work, which really, really helps. So that ref helps a lot. So let's talk about these dependent inconsistent systems and what happens. So if one of the rows of your reduced row echelon form has all zeros on the coefficient side and a non-zero number over here, then you have an inconsistent system because you're trying to say that 0 equals something else and it doesn't. If you have 0, 0, 0 on the coefficient side and you have another 0 over here, that means you have infinitely many solutions. You have a dependent system, and you must, again, give the general solution. That's very, very important. So let's look at some of these. So I'm going to do these again on your calculator because I want to practice and I want to show you what your calculator looks like when it does these. 2, -1, 1, 6, 3, 1, -1, 2, -1, 3, -3, 8. Okay, so let's look at your calculator and let's edit matrix B. Make this a 3 by 4 now. Okay, so again, I'm going to pause to put these in. Okay, once that is in, let's quit out of there. I'm going to go to matrix math, and I'm going to go, I know where it is now, so I'm going to go alpha apps for B, ref, and I want matrix B is the one that I put that one into. Now you see what happened. We ended up with the row reduced form gave us 1, -2, 0, 6, 0, 0, 1, 0, and 0, 0, 0, 0. So looking at this, what would you think? You end up with 0, 0, 0, 0. So you know that you don't know what z is, but look at this. Do I know what z is, actually? I do know what z is. I know that z is 0. I do have one solution. However, x and y seem to depend on each other because look at this one. So if I go x minus 2y, I'm going to rewrite this as is 6. So I know that z has to be 0, but I know that x has to be 2y plus 6. So I actually have a dependent system, even though I do have one solution, with the following. So we can call y to be some a, and I would have x equals 2a plus 6, y equals some a, any number, and z equals 0. And that's what would happen. So as long as z equals 0, it's this line right here is where the solution set is. So let's look at this next one. Let's put these ones in. So I'm going to go let's set up matrix C this time. I'm going to edit matrix C as a 3x4. Okay, I'm going to put these in while I pause. Okay, all in, matrix C. So I'm going to quit out of this, go back to matrix math. I'm going to go alpha apps, which brings up my B, and I'm going to go matrix C, number 3, and let's see what I get. 1 0 0 0 0 1 negative 1 0 0 0 0 1. Now this thing is trying to tell me that 0 z's equal 1. No. Actually, right, no. Because 0 can't be equal to 1. Therefore, this one is an inconsistent system. And there's nothing more that I can do. So I wanted to point these out especially because see the difference between having a 1 here and a 0 here. This just means that z is 0. This over here means 0 z's is 1. But 0 times any number has to be 0. So you can't do it. So that's the difference between these two. Okay, so that is it. And we will work on some more of these and different ways to do these.